Next, I think one of the most pivotal things that we need to discuss is going to be how switches actually allow me to be able to support simultaneous communications. Now, the way that we need to look at this is again, from a switch perspective. So what I'm going to do is I'm going to draw in my switch. And again, what I'll do is I'm going to put some interfaces on this switch. In fact, I'll make those interfaces a little bit bigger. And we already discussed that what I can do basically is I can subdivide my switch in such a fashion. In fact, I'll just go ahead and use the blue here. I could actually divide the switch down the middle by creating VLANs. So as an example, I could create VLAN 100, and I could create, basically at the end of the day, a virtual switch where this switch is actually pretending that it's going to be a separate logical switch from, let's say, this switch. So again, the idea is that VLANs allow me to be able to subdivide my infrastructure. Now, let's operate under the assumption that inside of one of these VLANs, see, that governs the fact that now that makes perfect sense. If this right here were VLAN 10, it stands to reason that this port could talk to this port, thus allowing me to have two simultaneous communications on the same switch, because at the end of the day, because of this virtualization construct where I'm creating a virtual local area network, or VLAN, it stands to reason that these guys can't see each other. Therefore, they're in separate collision domains. But remember, we mentioned the fact that the switches had the capability of being able to buffer information to keep from dropping that information on an interface by interface basis. Now, what if I were to add a third interface in this configuration? Actually, what I'm going to do is I'm going to add two more interfaces. I'm going to add an interface here, and I'm going to add an interface here. Now, obviously, these interfaces are going to have their own buffers assigned to them to be able to absorb collisions. But most importantly, it's going to be necessary for us to understand in this scenario that if I had 4 hosts, so let's say I have host 1, I have host 2, I have host 3, and I have host 4, that are connected, it's important to understand that based on the fact that these switches allow me to be able to intelligently engage interfaces based on the creation of my CAM table. So let's assume that this is an illustration of the CAM table, the content addressable memory table, or the MAC address table, whatever you want to call it. But at the end of the day, we already said that this is just a database, and it's a database, and I'm going to have a database per VLAN. So let's assume that this is the MAC address table for VLAN 10. Now, looking at this database, I'm going to make a record of ultimately the MAC addresses of each of these hosts, based on gratuitous ARP, based on non-silent hosts, based on ARP discovery, whatever that process is. So what we're going to see here is it's going to say, well, MAC address A is via 1, 2, 3, 4, 5, and 6. It's going to say MAC address A is reachable out of Ethernet 1. It's going to say MAC address B and C, so B, C, and D. So that's all 4 of these interfaces that are part of VLAN 10 are going to be on their corresponding interfaces. So 3, 4, and 3, 4, and 5. So that's the information, and remember, it's sorted on the basis of the VLAN number, the VLAN that's been assigned to the given set of interfaces. Now, the benefit here is that the way this actually works is if host 1 wants to communicate to host 2, We do this based on the process of forwarding, remember, provided the content addressable memory table has been populated. So in this scenario, A and B are in the database. So this switch knows that it can actually send information between these interfaces, and because of this concept of collision absorption, they're not contending. And the beauty of this is this means that if host 4 wants to communicate to host 3, it can do the exact same thing because host 4 and host 3 are going to be in the database. So the switch knows that the only interfaces that it needs to engage for that communication are these two interfaces. So you can see this allows me not only the ability to absorb collisions, not only the ability to be able to isolate my switches in such a fashion that they're going to be representative of logical or virtualized switches, it also gives me the capability of being able, in a forwarding scenario, to support more than one communication flow. And again, that's made possible via the intelligence that is baked into our switches, thus making a switch a very powerful and a very capable tool. Now, this governs the behavior of what happens inside of a physical switch. What if I want to take two switches and start connecting them together? We have a lot of things that we need to take into account. We'll itemize those in the next video, and what we'll do is we'll address each one of them step by step in order to be able to ensure that we are going to have a functioning and, more importantly, a loop-free layer 2 infrastructure. So we want it to be both function and be loop-free. So I'm Terry Vinson. I'd like to thank you for learning Data Center with me, and I'll see you in the next video.